Hey there and welcome back. So we talked about the Java Collections framework in the previous video, and let's look at some of the classes that implements these interfaces. How do they work in Java? So if we start with the ArrayList, and I'm not going to cover all of the classes, but let's take some commonly used data structures and collections so we can see how they're used in Java. So first we can take the ArrayList. That is a commonly used collection in Java. So if we make an array list, we can see here cars, and first off we have a class, a custom class that is called car. That is a basic representation of a car with a brand, a model, a color, and a top speed, just to have some objects that we can add here. So we're creating the array list that contains car, and let's just call this cars here, make it new array list. So if we write cars dot, then we get a list of the methods in our ArrayList data structure. We can see we have many methods regarding modification of the ArrayList. We can add, remove, get certain index, and modify our data structure, get the size, and so on. So we have our ArrayList here of cars, and then we can add elements to that. We can see C1, let's just copy this line of code here. Let's do C2, C3. So we add objects or elements to our array list, and then we can make for each. Let's just print out all the cars in our array lists. Yes. So let's build this code here and see what it looks like. Okay, so we can see we get a listing of our cars, of our array list, and we can also do cars get at some index. So we can apply 1 to get this car from the array list. So it is using an array underneath, and this also means that if we write the time complexities, if we have add element, let's just take the normal one here. This will be constant time because it will add it to the end. Then we also have add an element of in a certain index. That will be big O of n. And the reason is that the array list might have to move all the other elements to clear space to insert this element. So that can be, in worst case, all the elements if we want to insert our new elements in the first index. Then we have get at some index, and because we're using an array underneath, it is constant time. If we remove at this index, this will also be linear time, worst case, because we need to move the other elements back to have a nice array list afterwards. So that these are the time complexities for the array list. So if you do a lot of modifications on an array list, then you will have this big O of n time complexity. But if you are using your array list as, if you just want to index your elements, if you know the indexes there, this will be doable in constant time, or if you're adding it to the front. All right, so that is the array list first off that we have demonstrated here. Pretty simple, pretty commonly used in Java. And you can also, if you search on Google for collection Java 15, that is the version 15 of Java, you will be taken to this page on Oracle where you can see the interface collection. That is the core interface that dictates a lot of the methods that must be implemented. We can see we have add element, clear, contains, iterator, we have remove, size. So that is why we can see these methods in our array list, because array list implements the list interface and the list extends from the collection interface. Right, so in the next video, we will take a look at the LinkedList data structure that can do many of the same features, but has some different time complexities. So thank you for watching and have fun with this. Bye bye.